week 6, day 2, week 6. It's already Tuesday, right? The week is be flying, right? It's Tuesday already, believe it or not, and this is the second installation of our evening classes. I want to say a special thank you to everyone who decided to spend the evening with us. Truly appreciate it. So we're going to start off very, very easy, and then we're going to go from familiar to unfamiliar, like how we do every night. That's from familiar to unfamiliar. Okay, so let's begin. So we already did number 6. Wait, let me share my screen. I don't think I'm sharing my screen as well. So let me share my screen with you. Remember, tonight is math, then health, then general science, then health. So better than mine as well. Okay, so my screen should be sharing. Is it?
Yes, sir.
Okay.
Yes, sir.
Okay, so we ended with this question. We was on question A, and we converted 4,560 grams into kilograms. And anyone remember how did we do that?
We used the acronym thingy.
The acronym, yes. And what's the acronym? Anyone can remember the acronym that we used?
Knock him down.
Knock him down.
Good. So that's the acronym that we use. And I received a question asking, what about centimeters to meters? How would we do that? Okay, so I just want to...
Knock him down, cousin. Don't commit murder.
No. No. Okay, well, okay, so this... No. This is the last thing we saw. So let me extend this. We don't need this and we don't need this. So here... Okay, let me allow this person to come in and then we'll explain it. Oh, thought someone was trying to come in. Oh, yes, so Denari. So maybe it'll do well if I actually lay it out for you guys. What I mean is, it's very important to understand what these symbols mean. So let's say for example we have, so this is K, H, so knock him down. Let's deal with meters, right? Let's deal with meters for now. Knock him down, minister. Don't commit murder. Okay, so it's important to understand what each of these mean. This M is actually for millimeters, right? Millimeters. So millimeters. The very small. Like as you go from right to left, it gets increasingly bigger. So on the lower end of the lowest end of the spectrum for these ones is the millimeter. That's the millimeter, and then this one is definitely gonna be your what?
Centimeters.
Definitely centimeter. So this is centimeter. Sorry, someone's asking to join. Don't want to have them waiting. Okay, good. So yeah, so this one is centimeter. So centimeter. Then the D. What does the D stands for? Anyone remember?
Millimeter.
Decimeter.
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 Say it again.
Decimeter.
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 Decameter.
Deca. Spell it.
Decameter.
Say it again.
DECA. Decimeter.
DECA.
Yeah.
and not DEKA.
We were in that.
We can write it. So let's do it. So this one is for millimeter. This one is centimeter. And right after that, let's do this one. So the D is gonna be for decimeter. Decimeter. So DECIMERT or RE. Either one works. So that's decimeter. That's so the first one is
Just
M.
we didn't say decimeter.
Say it again.
We didn't say decimeter.
Decimeter. You mean if y'all didn't say it?
Yeah.
Y'all probably did. Y'all probably did.
Mm.
He did.
Y'all probably did.
So decameter is larger than decimeter.
Say it again.
So decameter is larger than deci.
Yeah, deca is larger.
Alright.
Deca is larger. All right, and then we have M, which is the meter.
Meter.
And then the D, which is for deca.
Decameter.
Yeah, deca. And the H, which is for
Hector.
hecto.
Hecto.
Hectometer. And then the K, which is for, of course, kilometers.
Kilometer.
So it's important to understand that as we go from right to left, we get increasingly bigger. Okay, so that's important. As we go from right to left, we get increasingly bigger. Okay, so if we want to include the, sorry, give me one moment to put this in for, let me allow Natalia to come in. So if you want to include the actual units themselves, like with the units we'd use for this one, what is the units for millimeters? You remember? The units for millimeter.
ML.
M what?
MM.
Yeah, mm. Very good. That's millimeter. The units for centimeter is going to be what?
CM.
cm. Very good. For decimeter, it's going to be what?
DM.
DM.
Yeah, dm. Very good. For meter, it's going to be what?
M.
Just simply m. For
Yeah.
decameter, it's going to be what?
DK.
dk. So that's dkm. For hectometer, it's going to be hm.
HM.
And for kilometer, that's going to be km.
KM.
Okay, so that's what we dealing with. That's what we operating with. So we have kilometer, hectometer, decameter, meter, millimeter, centimeter, and decimeter. And like I said, that as we go from from right to left, we get increasingly bigger. So someone asked me, what about if we're trying to move from centimeters to meters, how would we do it? And that's a good question. And I'll show you how. So if we're trying to move from centimeter to meters, or someone else again.
So you would multiply.
Okay. So remember, if we're moving from centimeter to meters, so that means we're gonna start from this one, right? And we're gonna go to what? To meters, right? So from centimeters, so let's say we had like say we had 8 centimeters, right? And we want to convert that into meters. We want to say like how much meters is that? So 8 centimeters equals to how much meters, right? Let's say we wanted to do that. We would start from centimeters and then we'll go 1 and 2. And so we reach 2m just by 2 rotations. So that means we're going to put 1, 2 zeros in front of the 1. So that means that the number that we're dealing with is here 100. Now, we are moving from a smaller unit to a what? A bigger unit. And every time you're moving from small to big, you're going to do what? Divide.
Multiply.
From small to big. Small to big.
Oh, multiply.
No, from small to big.
Subtract.
Divide.
Right.
Remember, every time you move from a smaller unit to a bigger unit, you divide. So we're going to divide by what?
100.
100.
100.
Good. So that means that 8 centimeters equals, open bracket, 8 divided by 100 meters. And what is 8 divided by 100? Remember, if we have the 8, we're going to move the decimal place twice to the left. So it's going to be 1 and 2. So this is where the decimal place is going to be now. And then we're going to put a 0 here and a 0 here. So 8 divided by 100 is 0.08. Okay, so that's how we would convert something from centimeters to meters.
Excuse me, Mr. Petit.
Alright.
I was saying, like, if you had your camera on, you could have showed them, like, how you do your arms with smaller to big.
Yes, to get it. So, like, from small, you just cross your arms, right? So that's small. And then when you go big, you extend your arms out. So that means it's open wide. So if you go from small, cross arms, to big, open wide, then you would see that your head and your navel forms the 2 parts of the division, and your arms would be the line. So you know if you move from small to big, that's cross the open wide, you know that's divide. But if you're moving from big to small, so that means you start wide, big, and you go small, then you would end up with a cross. And so that means you know if you're moving from big to small, you multiply. Okay? So that's the way how I remember it. Okay. So the answer here would be 0.08 meters. So that's how we would use our acronym to do it with centimeters. Okay, any questions for me on that?
No, sir.
No? Okay, so that's good.
So when you're changing it to
So,
grams,
Mr. Petit, the one you trying,
Go ahead.
so when you're changing it to grams, you're changing the M to grams, you're changing the M at the end too.
The M will just be milligrams. You understand that?
Okay.
Okay.
And it only changed the grams and the meters, right?
Yes. The only letter that changes is that big M in the middle.
So that's the only letter you have to change when you're trying to find.
Yeah, that's the only letter you have to change. The rest would follow suit because this will just be
Okay.
milligrams, centigrams, and so on.
Okay.
Okay. So moving right along. So let's do the next question in the sheet. Oh, so now they ask us, they tell us now that 1 kilogram equals to 2.2 pounds. If we know that 1 kilogram equals to 2.2 pounds, express your answer from part A in pounds. So here they give us the unit of conversion, and they're saying, hey, if you know that 1 kilogram is equal to 2.2 pounds, then express your answer from part A in pounds. Now remember what we got for part A? If we remember that in part A.
Yes, so we get 4.5560 kilograms.
So let's go back here. So in part A, we got 4.56 kilograms. That was our answer. So we had 4.56 kilograms. So again, our answer for A was, let me just do it. So answer for part A was 4.56 kilograms. Now you may say, well, Mr. Petit, what happened to the zero? Well, we don't need the zero, just like how we saw yesterday. We could just keep it as 4.56 because that zero in the back doesn't matter. So we have 4.56. Okay, so 4.56 kilograms. So answer for part A was 4.56 kilograms. Alright, so that's what we got, 4.56 kilograms from part A. Now we need to change this into pounds. Now the good thing is that they give us it, and the reason why they give us it is because no one walks around knowing that 1 kilograms is equal to 2.2 pounds. Like, that's not a common one to remember. I mean, definitely I almost over-exaggerating. Certainly some persons know. But as a general rule, we don't usually memorize that one. And so, them knowing that that's not a typical one to memorize, they give you the unit of conversion. And they tell you that 1 kilogram. Okay.
You was just not open your hand. As you know, serious to put on it.
Alright, sorry about that. We have an interesting night today. Interesting night. Boy, this is interesting. Okay, so 1 kilogram equals to 2.2 pounds, right? And this is the symbol for pounds. LBS. Okay, so let me set this straight for you. Okay, good. So we have 1 kilogram equals to 2.2 pounds. Now that's very important to consider. We know that 1 kilogram is equal to 2.2 pounds. What if I wanted to know how much was 2 kilograms?
Multiply
2 by 2.2. Yeah. What if I wanted
2.2.
What if I wanted to know how much was 3 pounds? I mean 3 kilograms.
Multiply by 3.
Multiply by 3. Good. So in order to figure out the answer for this question, I must multiply, because I want to know how much is 4.56 kilograms. So what must I do?
Multiply by 2.2.
Multiply 4.56 by 2.
2.2.
Good. So that means that 4.56 kilograms is going to be equal to 2.2 pounds multiplied by 4.6, right? And so 4.56 pounds multiplied by 2.2 pounds multiplied by 4.56 is going to be equal to what? 2.2 times 4.56. Anyone got any answers? When you multiply those two?
10.032.
Yeah. 10.032 what? Pounds, right?
Yes, sir.
Go ahead, someone is trying to ask the question.
No, I said yes, sir.
Okay. Who's that speaking? Trying to distinguish the voice.
Rashay.
Rashay. Okay, so that's how we would do it. We'd say in order to figure what is 4.56 kilograms, that's going to be equal to 2.2 pounds times 4.56. When we multiply them, we get 10.032 pounds. Okay.
What was the question again?
The question was to, let me show you the question. The question was to take what the answer we get in part A and express it in pounds, knowing that 1 kilogram is 2.2 pounds. So again, they said that 1 kilogram is equal to 2.2 pounds. That's what they tell us. And they said, okay, if you know that, then take your answer from part A and express it in pounds. We know that our answer that we got from part A was 4.56 kilograms. Now again, 1 kilogram is 2.2 pounds. So that means that 2 kilograms would be 2 times 2.2. 3 kilograms would be 3 times 2.2. 4 kilograms would be 4 times 2.2. But here we want 4.56 kilograms. So that'll just be 2.2 times 4.56. And we'll get 10.032 pounds. Okay, so better than mine there. I should mention that for those who are doing this by hand, notice that you have 2.2 and 4.56. Notice that there's, after the decimal place, there's one number. And for 4.56, after the decimal point, there's two numbers to the back. So that means that you need to move the decimal place 1, 2, 3 numbers in front. So that's why the decimal point is right here with the 3 numbers at the back. So better than mine.
That's how I was wondering why the decimal up there.
Yeah. The decimal would
But you can repeat why it up there again.
Because it's 3 numbers. So we have this number behind the decimal point, that's 1. And these 2 numbers behind the decimal point. So in total it's 3 of them. So you have to move the decimal point 1, 2, 3. You understand?
Okay. Yes, sir.
Okay. Okay, any other questions for me?
No, sir.
No, okay, that's good. All right, so send that in for me. Let me see how you did that. And I also want to have a good idea of those persons who are participating as well. So send in the notes for that one. It's just a continuation of what we did yesterday. Okay, now let's move back to, let's go to unfamiliar. Or it might be unfamiliar to you. Did we ever finish this graph? No, we didn't. Okay, so let's finish up this graph. So this is, so we was able to find the missing value of y. We was able to find the missing value of x. And we was even able to graph it. Everyone should be able to do C. Using the same scale and axis, draw the graph of y equals to 7 minus x. Okay. All right. So this is what type of equation they asking us to graph? Anyone can remember? Y equals to 7 minus x. Say it again.
You know?
A linear equation. Very good. Let me ask you this. What is the slope of this linear equation?
7. X.
Boy, y'all don't study. Y'all don't revise.
0.
Y'all don't revise at all. Man.
2x. 2 over x.
2x? No.
2 over x.
No.
7.
It ain't 7?
That means 0.
No.
Is it 1? 1?
Isn't it negative X or something like that?
Close. That's the closest.
Because I know the 7 would be the y-intercept, right? So
But the 7 is the y-intercept.
So it gotta be negative X or 1. No, 1. It's 1, eh?
Close.
For real?
Close.
0?
No, not 0. Alright, so let's remind ourselves of what's happening here. Remember that if we have y equals to mx plus b, what is the slope? M, the slope is M. So the slope is the number in front of the x, right? What is the y-intercept?
B.
So if we compare that to this one, we have y is equal to 7 minus x. Is this in slope-intercept form?
No.
No, sir.
Gotta rearrange some stuff. So we just have to put the negative x first. So it's gonna be negative x. It's a positive 7, right? So plus 7.
Yeah.
Good. All right. So what is the slope? The slope is gonna be, what's the number in front of x?
Negative 1.
Negative 1.
Yeah.
Negative 1. Thank you. What's the y-intercept?
Seven.
Positive 7.
Positive 7.
Yeah. But y'all have to revise now. Y'all really have to revise. Because we spent a whole week almost just dealing with linear equations. So please revise. Alright, so and then the y-intercept is 7. Good. So we know that the slope is negative 1. We know the y-intercept is 7. But they want us to draw this graph, right? Remember how we always draw the graph? We always start with the
y-intercept.
yeah, we always start
Me and y-intercept, sorry.
yeah, we always start with the y-intercept. So let's draw this graph on the same graph. of that that reciprocal function. So what I mean is, let's go back to our reciprocal function here. So we have the draw.
On the same as this, right?
Yeah. So we have the draw. We have to draw the graph here. So remember, we gotta first point out our y-intercept, which is what, 7. So it's gonna be right there on the y-axis. So 7. That's the first point that's on your line. Okay, so 7 is that. And then the next point on our line, oh my god. The next point on our line is we're gonna get it by using the slope. Now this is -1, but we know that's over 1. Okay, so -1 over 1, the same thing as -1. So we know that the top tells us left and right movements. Sorry, the top tells us because the slope is a rise over 1. The top tells us up and down movements, and the bottom tells us where do we go left or where do we go
Side to side.
yeah, side to side. All right. Now regardless if it's positive or negative, we always go what?
To the right? I mean,
We always
yeah.
go to
To the right?
We always go to the right.
Right, sir.
The negative just tells us that we go down, is it not? You remember that? The negative here just tells us that we go down, but we know that we're going. To the right once. So this tells us that we go move downwards, right? Move downwards. How much times?
Once.
Once. Why downwards? How do we know it's downwards?
It's a negative, so you go lower.
If it's negative, so you go downwards. If it's a positive, you go upwards. So this one says move to the right. We always move to the right, regardless of what's at the bottom. So move to the right once. So down once and to the right once. Okay, so let's do that. So our first point for our graph was 7, right? That's the y-intercept, right?
Yes, sir.
And then the
Yes,
second
sir.
is going to be, remember, we go down once, then right once, right? And we also go down once. Okay, so this is telling us go down once and to the right once. So that means we'll end up here. Down once again, to the right once, we'll end up here. Down once, to the right once, end up here. Down once, to the right once. Down once, to the right once. Down once, to the right once, and so on. That's what the slope does for us. Okay, so based on that, we're just gonna go down once and to the right once. So that means that this is the point that should be on our graph. So let's plot that point. Remember, how much points do we need in order to graph a line?
2.
We only need 2. Now this is the first point. This is the second point that we have, and from just these 2 points, we can extend. We can continue the line. So we could, but I don't want to do it like that. I just want to put some more just so that you could be able to see it. But we could just from these 2 points draw the line already. But we know this. We know the slope is -1, so that means we're gonna go down once to the right once. So this is also on our line. Again, down once to the right once. This is also on our line. Okay, so down once to the right once. This is also there. Down once to the right once. This is also there. Down once to the right once. This is also there. So that's what the slope is telling us. Remember, linear graphs have a constant slope. So down once to the right once. This is also here. Down once to the right once. Okay, down once to the right once. Okay, I think you all get the picture. So let's draw the line that intersects these points. So the line is gonna be something like this. Okay, so that's a good one. Do we see that, or I need to increase the size?
I can see it.
Okay. Let me see if I could change the color at least.
Mr. Petit, do we label that one as well?
Yeah, we have to label it. So, what do we label it? We label it as what they have it in the question. So, they have it as
Y is equal to 7 minus x.
7 minus x. So that's that line.
In the exam, when they write it on the paper, should it be written in pen or pencil?
You mean the graph?
I mean, like when you labeling it.
Pen.
Oh,
So, Mr. Petit,
Yes, sir.
so we draw the graph. I mean, we do the graph in pen or pencil,
No, pencil, sure, certainly.
but the lines will be black. How do you see
No,
it?
she's meaning the labeling. You could put the labeling in pen.
But I mean, like
I
drawing it.
draw a second pen.
No, you don't draw in pen. You draw in pencil.
Okay.
Make sure your pencil is sharpened and dark so they can
It
see.
doesn't seem like
Yeah, you have to make sure your pencil is sharpened and dark. Don't use pen on them people exam.
Mr. Petit, that's difficult to draw though.
What's difficult to draw?
How you have to like the lines in the middle.
What do you mean? It's difficult to draw that?
Yeah.
For real? I mean, I guess it takes a lot of getting used to, but I mean, it's just like connecting the dots to me.
No, not the dots. I mean, and like the graph
Oh,
on
you
the
mean
whole.
the curve.
No, not the curve. I mean, entire like the lines that I have to put the lines in the middle.
What lines you got?
Like the lines.
I mean the
in
grid
graph.
itself, the blank grid itself.
No, they can give you the grid, you know. They can give you the grid. They can give you the grid. So that's okay. I mean, it does take some getting used to though. But it's alright. Okay, so alright, so now we have this line running through it. Y is equal to 7 minus x. So what we need to do now is we need to continue back on this. It says from your graph, so you have to use your graph, okay? Estimate where the values of x, estimate the values of x where the curve and the line intersect, okay? Estimate the values of x where the curve and the line intersect. So we have to use our graph. However inaccurate our graph is, whatever, but it have to be from our graph. So that's 2 points.
So they saying even if you graph it wrong, they still won this in this section on your graph.
On your graph, yes. Because if you don't do where it is on your graph, they can't give you what they call follow-through marks. Okay? And so follow-through marks basically mean is that they could just mark you wrong for your graph, but all the other answers that you have that are based on the graph, if you keep them, they'll just mark it right because you was looking at your wrong graph.
What you mean?
Yeah. Okay.
Can I see the question?
What I mean is, okay, let's say you draw this graph wrong, right? It was off, right? So they'll just penalize you in the first one, but they ain't gonna penalize you again. If you understand what I mean. So they'll say, okay, well, clearly y equals to 7 minus x was wrong. So okay, so they got that wrong from there. But if now you estimate correctly based on the line that you draw, they'll mark it right because they'll say, okay, he was looking or she was looking at the graph that was in front of them. So that's why it's important to be true to your graph, okay, whatever it is. So they'll mark you wrong here, but they'll give you it right here if you use your graph, okay. So they call that follow-through marks. You understand that?
So
Yeah.
Okay.
So they're giving you it right for your wrong graph.
Yes, sir.
Yeah, right for your wrong
Yeah.
graph. So stay true to your graph. So so that's cool. It's the same thing with geometry. The same thing with geometry. If they're gonna mark you based on your graph. So if you measure it and the thing say 59, don't put 60. Say 59, because that's what your graph say. Okay, so moving right along. So okay, so where does these things intersect? Let's give it a notch. So from my graph, I'm gonna say from my graph, and then after I give it from my graph, then I'm gonna show you what is the correct answer. Hopefully they are the same, but from my graph, they intersect right here, and that is the point. On the y-axis, this is 6.4. Let me write that down somewhere. So on the y-axis, I'm getting 6.
Mine too, Mr.
6.4. Yeah, I'm getting
Yes.
6.4. So for the y, I'm getting 6.4, and 6.4 because if you look carefully, right, this is 6, right? This is 6. If we go up 1, this is 6.1. 6.2, 6.3. Then right here is 6.4. We see that? Or I need to do it again?
You do it again.
So
Yeah.
again, this is 6, right? The 6. Right up here is 6.1. Then right here is 6.2. Then right here is 6.3. And then right up here is 6.4. You can also know because the next one is 6.5. And one step below 6.5 is 6.4. So for my y-axis, I get 6.4. Go ahead.
So, it's going to start coming from the bottom.
Again.
So you always see where you come from 6, right? So you can't come from the top of 6.
Okay, top of 6, like from where else? Like say like from up here.
Like from the 5th line, go down.
From the 5th line, go down. So from 5 and then go down.
I think you mean 6.5.
6.5 go down.
Oh, 6.5. Yeah, I could do that. So if this is 6.5, then go down to 6.4. That's another way to think about it. Okay, so that's 6.4. So this one, we could easily know what this one is. This block here is 0.5. I don't know if you all remember that. This is 0.5 right here. This is 0.5 line. You know what I'm talking about? This line is 0.5 because this one is 0. So this one was 0. This one is 0.5. And so if we go one notch, it's going to be what?
0.4. 0.4.
No, 0.6.
And you say you're going down?
No, look. This is 0. This is 0.5.
Yeah.
Right? And I go over right here. What would that be?
Oh, 0.6. Sorry, I thought you was going down.
That's okay. You can repeat what you're doing right now.
Okay, I'm trying to find x value. So if we look carefully, this is 0, right? This whole line is 0. And here is 0.5. And then here is 1. Okay? So this is the line 0.5. So I'm going to stay on this line 0.5. So remember, this is the line 0.5 in the middle there. You see that, right? That's the line 0.5. We're still on it.
Yes.
Now, if we go over one jot, that's going to be
0.6.
0.6. You see what I'm saying? So
Yes, sir. Yeah.
the x-axis here is going to be 0.6. And the y-axis is going to be 6.4. Okay, so that's the numbers I'm getting. Anyone get any other numbers on their graph? So based on my graph.
Yes, sir. I got 6.5.
6.5. And what you got for the x?
You mean like where they intercept?
Yeah.
Yeah, it would be on the 6.5 line.
But you need to give me two coordinates. I need the x-axis coordinate and I need the y-axis.
Okay, well, let me count it like with you. Give me 1 minute.
So I get 6.4.
Okay, what you got for x?
0.5.
Okay, on the x-axis, I got 0.5 and I got 6.5 on the y.
Okay. Okay, so I got 0.6 and 6.4. Remember, stick true to your whatever your graph say. All right. Okay, so now let's go to. Okay, now let's go to this one. This one here this is the next point where they intersect, right? Agreed?
Yes, sir.
Yes, sir.
Good. So if we look carefully, this is the line. So this is 3.
3.5.
This is 3, right? This line is 3.
Yes.
If we go up, this is going to be 3.5, right? 3.5.
Yes,
So
sir.
this is the line 3.5. Now we got to find where they intersect. It's going to be above right here. So that's 3.6. Okay. So the y-axis, that's 3.6. So again, if we look carefully, They intersect right here. At the bottom here, this line is 3.5. Again, at the bottom here, this line is 3.5. One more time, this line is 3.5. If we go up, we'll go up 1, we get to 3.6. Once again, this will be 3.6. Again, this is 3.6. But 3.6 for the y-axis. Now for the x-axis, if we go down, for the x-axis, go down, go down, go down, go down. We are on this line. So that would be, what anyone knows? What it would be? Right here, this line.
3.4.
3.5.
4.
So we labeling where the lines connect and can join it.
Yeah, where they intersect. Yeah, right there. So this is going to be 3.4. Okay, 3.4. So I got 3.4 on the x and 3.6 on the y. So let's label them. So they intersected. Let's use a different color. Say orange. They intersected right here. All right. And we said that this is the point 0.6, 0.6, comma 6.4. And then they intersected also here, right? And that's the point 3.4, 3.4, comma 3.6. Are we good?
Yes, sir.
All right, so this is 0.6, 6.4, 3.4, and 3.6. All right, so that's how we would do it. All right, so make sure that on the actual question, notice what they said. They said answer this entire question on the graph paper provided. Okay, so that means that on the graph paper, so on the graph paper, where are we? So the graph paper, where are we? So this is the graph paper. So you're gonna put your graph on this answer. You're gonna put your graph on this particular paper. Now, make sure also state now they say answer this entire question on the graph paper provided. So that means that all these different answers here, they need to go on the back of the graph paper. You understand what I'm saying? So the missing value for y needs to go on. So first of all, you have to rewrite the table. That's the first thing. And you're going to put it at the back of your graph paper. The graph paper has two sides. Okay? So when they say answer the entire thing on the graph paper, you have to use the back of the graph paper, which should be blank, and you're going to answer the rest. That's going to give you space to answer the rest of these. So when they say from your graph, estimate the values of x, make sure put it on the graph paper at the back. And also put it on the actual graph itself. So there's no mistaking of what you're doing.
So you have to put like identify the question you answer and then answer it.
Yeah, identify the question that you're answering. So say for example, we have 11A. So we put 11AI, then we put 11AII, and so on. Okay. All right. Now the next thing that we're gonna do is
You can go back and graph, please.
You can go back to part C, please.
go back to part C. Okay, so let's first go back to the graph, and
Can you make it bigger? All right.
then I could go to back to part C. Did anyone graph look like mine's?
Mr. Bd.
Go ahead.
So the first point, that's the X, right?
The first point is the X. It's the X point, yes.
Okay.
All right, send a picture of the graph that you have. This is the completed thing. This is what they wanted us to graph.
Mr. BT, isn't this like how business stock starts? You know, like when it drops and rises up? Is that something related to that?
Definitely something related to that. All that is maths, functions and stuff like that. That's how they could tell. At least that's how some people just tell. They use maths to predict it. But it starts here at a fundamental level. Okay. Okay, send me the pictures of your graph already, please. I'm only receiving some pictures from some people. Very good notes, Miss Gardner. But you all have to study though. I can't stress that enough. Some things we went over, and I'm surprised that you didn't know. This one you're talking about, Mr. John. Yeah.
Yes.
Yeah. Yeah. You have to study. Have to study.
Okay.
Yeah. What kind of problem? I remember when I was in school, I used to skip school to study. Sounds weird, right? Yeah. I used to not go to school sometimes just to study at home.
I was about to say.
Yeah, that's true. And exam time when and exam time when I realized that exams on there and they ain't giving us no time. They just teaching, or we just goofing off in school. I'd say, you know what, let me stay home and spend majority of the day just studying. So you have to
Like study like a particular subject or all subjects.
I used to mix it up. So I'd say like a few hours for this one, a few hours for that one, whatever. It was depending on which exam I was having first. So if I knew that biology was first, then physics was second or whatever, then I would spend more time on the ones that are the closest. Or also the ones that I feel that I am the weakest in. So but you have to study though. It ain't gonna happen just by coming to class. Okay, you have to pour in the time. Okay. All right. So
Can we do some more of this? Some more progress from this?
we can, but right now I don't have no other question at hand on this particular one. But look through the past papers. Look through the past papers. You should see stuff like these. They like to bring them in the back.
So this the paper one. So this paper 2 or 3?
3. Okay, so all right. So let's go to let's go to our familiar question. Oh no! Before I do that, I want to verify our solution. So we got these 0.6, 6.4, 3.4, 3.6. I want to see how close we are to the actual answer. Okay, so I'm going to use the graphing calculator to check. There is an algebraic way that we could check to find out the intersection, but I really don't want to do that way right now. There's going to be 3 plus 2 over x. Is it that? I feel like I'm doing something wrong. What is it? What is our equation? Our equation was what? Okay, 3 plus 2 over x. Yeah, you're right. 3 plus 2 over x. And then the second equation was y is equal to 7 minus x. Good. So let's see where they intersect. Okay. They intersect at
Oh, you got it.
0.5 and 6.4.
Close enough.
Close enough, eh?
Good. Yeah.
Close enough. Yeah, that's wow, that's solid. Because
You on it though, right?
say it again.
Aren't you on it?
If I what you mean I'm on it. I'm on job.
Like as in you have 6.4 and you have
Yeah,
0.
we have 6.4 and we have, if you round this is going to be 0.6.
0.6.
Yeah, so wow. That's perfect. Wow. Awesome. And then here, what is this one? 3.4 and 3.6.
Yeah, we got it.
There we got it. So with all our interestingness, we might still, do something right. All right. Okay, so that's good. That's comforting. That's why they can't let y'all go on these exams with these calculators, because otherwise, I'll be able to get
The whole exam over. Easy, eh?
You say we can use calculators?
no, not graphing calculator. Not graphing.
So can they tell if you use a graphing calculator?
Say it
Take
again.
a note?
Can they tell?
Let's don't risk it.
Don't risk it. I wouldn't risk it. Don't risk it. Don't risk it.
They even inspect the calculators.
I mean, I don't know. That's the thing. It depends on your invigilator, though. Like if
Like you said, they're expensive. So
if I am your invigilator, sure, trust me. I check in the calculator. But
Like if it's a math thing, they would know.
Teachers, like they don't have math teachers be in the room, eh, when they're having a math exam, right?
they don't allow that. Math.
Yeah, so we could. No math teachers. We could.
That's the thing. You gotta first have to know how to use the graphing calculator, and then you have to pay for it. Go ahead.
When you post these videos on YouTube, they can watch this the same day you post it.
Who they?
Like anyone.
The same day I post it? Yeah.
Like it's visible to the world.
No, it ain't visible to the world. I have it unlisted. What, you want to make it visible? What? No, it ain't visible to the world. Find the value.
So only I saw the ranking.
Yeah. So find the value of 4 plus. Oh, yeah, this is very easy, man. This is application of PEMDAS. So everyone should get this right. If you can't do this, boy, I'll say fast and free.
6.
4 plus 5. What's the first thing that we do though? We have
multiply,
right?
Multiply.
And the reason why we multiply is because
the order of operations.
Because order of operations, right? Yeah. It says that we always multiply before we subtract or add. So we're gonna multiply, so it's gonna be 4 plus, what is 5 times 2?
10.
5 times 2 is 10. This is 10 minus 8 equals 2. Now we add, right? So what is
6?
Yeah, so
6.
4 is what?
14.
I guess 6.
14.
14 minus 8.
Oh, okay.
6.
8,
6.
9, 10, 11, 12.
6.
6.
6. Very good. So 6 is the answer here.
See, wait, never mind.
We good?
Wait.
Okay,
Yes,
I have a question. Not a question here, but I I add 4 plus 6. I know you say times first. I added 4 plus 6 times 2 minus 8, and I still got 6.
You added 4 plus 6?
Sorry, 4 plus 5.
Oh, no, definitely don't do that. Definitely don't do that. That's wrong.
Was it in a calculator?
No, I understand what you're saying, but I still got 6. Why is that?
Was it in a calculator?
One moment, Nancy. That's just a coincidence.
Oh, okay.
It doesn't work.
Okay.
Okay. I'm glad you raised that. You always multiply before you add or subtract.
Okay. So this question is a trick question.
Yeah.
Nigga, you
Okay.
calm down.
Okay. Okay. Nancy, you had a question? No?
Pardon me?
You had a question?
No, you see, I tried to do it the way she just said it, and I was trying to figure out if she used a calculator because the calculator automatically does it for you, but if you do it by hand, you're gonna get 10. I was trying to figure out if she used a calculator when she was doing it.
So if you just write the answer,
No, man.
you get the full marks?
No, you wouldn't. No, you
Very
wouldn't.
simple.
Oh!
You wouldn't. The marks is definitely for some of the work. One for the answer and the rest for the work. And so you want to show how you got that.
So they would half you, like
They'll just give you 1 mark for the answer. Okay? And the rest of the points.
Don't see how you get that answer.
Yeah, like how did you? Was you looking at Nancy's paper or who paper you was looking at? Okay, so write 0.007 as a fraction. So you're gonna take this decimal and write it as a fraction.
Would that be 7 over 10 or no?
Close, not over 10 though.
7 over 100?
7 over 100? No.
1,000.
Very good. 7 over
I noticed that.
Oh, I blind.
7
That's
over
all 3 zeros.
3 zeros. So it's because it's how much numbers? 1, 2, 3 numbers to the right of the decimal point. We have to put how much zeros? 3 zeros.
3.
So
I don't get how I only saw 2.
0.007 is equal to 7 over 1,000. Now, can we simplify that further?
Mr. Petit, before you go further, right?
Yeah, go ahead.
Can this also be written as 0.7 over 100?
0.7 over 0. You can, but they don't mean that type of fraction. They mean a fraction.
But would it be right though?
No, it wouldn't be right. I mean, it would be equivalent. It would be equivalent, but it wouldn't be right because they want regular fractions where the top and the numerator and the denominator are integers. So that's what they're talking about. You understand?
Yeah, I understand.
So what if we had 0.009? How would you write that as a fraction?
9 over 1,000.
That would still be 9
over 1,000.
9 over 1,000, very good.
What if they had more than 1 digits?
What do you mean?
What if they had 0.089?
Yes.
Right.
So 0.089 is going to be 89 all over 1,000.
Miss Petite, so it's always over 1,000?
yes.
It's over 1,000 because it's three. It's
4
three digits.
numbers. I mean, 3
numbers,
digits behind the decimal.
Behind the decimal. So we could do one where it's not over 1,000. So for example, if we have
0.08.
say 5 or something like that. What would that be?
5.
5 over.
Would that be 5 over 100?
5 over 100.
Yeah, 5 over 100 because
Okay.
it's 1, 2 numbers behind. What if we had 0.26?
26 over
6
10.
over 100.
26 over
100.
100.
Oh.
Hold on.
Nice.
Yeah, then 5 over 10.
Say it again?
That's not 5
26
over
over
10.
100.
No, it's 5 over 100. Because it's 2 digits behind the decimal point. Similar
Okay.
to this one. And if we had simply 0.9, what would that be?
9 over 10.
That'd be 9 over 10?
Yeah.
9 over 10.
9 over 10.
Yeah. So hopefully you get the pattern. We just put the top number over the number of however number digits you have behind the decimal point. That's how much zeros you put in front of the 1. So it's 3 digits, so you have 3 zeros in front of the 1, so you have 1,000. It's 2 digits, so it's 2 digits, so it's going to be 2 zeros in front of the 1, giving you 100. Similarly, it's 3 digits here behind the decimal point, so it's going to be 3 zeros in front of the 1.
So, T, why are you saying it mathematically?
Say it again.
Why are you saying it mathematically?
How you want me to say it?
2 zeros behind the 1.
2 zeros behind the 1. Oh, I mean, behind the 1, in front of the 1, once you get it. Once you understand what I'm pointing to. Depends on, you're a physics guy, it depends on reference.
Question.
Yeah, so you was referencing the decimal place, right?
Go ahead.
No, I was saying Mr. Battle was asking a question before me.
Oh, you see?
No, I ain't finished. It's just ranting.
Okay.
Okay, I was just saying,
Yeah.
what all have 0 point some number? What if we have 1.90?
Okay, in that case, it wouldn't be a fraction, it would be a mixed number.
Okay.
Yeah. So
Alrighty.
yeah. Okay, so that's it for that one. That was, so we finished that paper. Pretty much easy questions. And so now we got to go back to this one. So let's go to this. Probability.
I don't like it.
Yeah.
Oh boy, let me set up for this one.
Let's do our probability now. Okay, so hope I remember probability. We spend a lot of time at probability.
It's so hard.
It's not hard. It's interesting.
No, it's hard.
It says in a club of 30 members, 18 are girls, 6 are left-handed, 3 are left-handed boys. The table is to show the members, in each category. Copy down and complete the table. And so we're gonna complete the table right now. So they gave us some information, and it's important to understand what this table is saying. So this girls, right? This row is for all the girls, and the girls either could be left-handed or they could be right-handed. Now, again, this is the row for girls. So how many left-handed girls are there? If we know that there are 18 girls,
6.
there are 18 girls. There are 18 girls.
It's 6 over 18.
So it's 9.
3.
I'm starting to saying that 18 girls. Oh, we gotta be careful. Be careful now. There are 18 girls. Look at this. How much girls we have altogether?
18.
18.
Good.
So you're
And
saying
6
it
of
could only
them
be
are
3?
left-handed.
Yeah, if we know that 15 are right-handed, how much are gonna be
Would it
left-handed?
be 12?
3. So
Three.
3.
Oh, so you're saying some share both then?
No, I'm not saying none share both. There are
3.
18
I said
girls.
6 are left-handed, so
No, 6 are
18 girls.
left-handed refers to
3.
Not left-handed.
6 are left-handed doesn't refer to just the girls. It refers to both the
reverse
girls and the
men.
boys. Be careful.
Oh, so it'll be 3.
Yeah. So there's a big comma right there. That means 18 are girls, comma, 6 are left-handed. That 6 are left-handed refers to the members. So out of the 30 members, 6 are left-handed. It doesn't have to be girls. So for left-handed girls, it's going to be so left-handed. Someone mic is on. Please mute it. So for left-handed girls, it's going to be, remember, 18. That's how much girls we have, minus 15. That's how much right-handed we have. So it's going to be 3 girls. So 3 girls are left-handed. That makes sense because usually there are more right-handed people than left-handed. Any left-handed people there? Any left-handed?
Yes. Yes.
Yeah,
Hello. Yeah.
what? Kennedy, you're left-handed?
Yes.
What? What is this?
I'm known for that in my class.
Wow.
Yeah, it was so strange. I was only left-handed person in my class. I was like, what?
Wow, this is crazy.
I mean, they were saying that we were dumb. Then I was, said me.
Oh, wow. My best friend is left-handed, and it's his handwriting. It's I'm like, how do you do it? How do you do it?
I thought left-handed people couldn't write, but some in my class is very good.
That's good. They're regular people.
You know how bad they
They're
talk
human
about
beings.
left-handed people?
Like,
Do you
I
see
saw
why? You see why?
my cousin is right horrible, and then some
But
of
you
my
see why they
class
talk bad
is
about us? Do you see?
Yeah,
Do you see?
I
It's
see.
bias, honestly.
Discrimination.
Yeah, discrimination. All right. Okay, so we want the boys. Okay, so all right. So three boys are left-handed. Did they tell us how much boys in total? No. So we got to be careful because we know that this is very important. We know that there are 3 left-handed boys, right? And we're trying to figure out how much right-handed boys are there. We already have the 6 for the, and they said it has 30 members. 3 boys are left-handed. 3 boys are left-handed. So if 3 boys are left-handed, but we don't know how
Would it
much
be?
boys there are in
Would
total.
you add up the girls? I mean, would you minus the girls from the 30 and then minus 3 because the left-handed boys, and then you get the right-handed?
Say that again.
Yeah, that
If
makes
you
sense.
minus the girl, because it's 30 in total, so if you minus 18,
There's
Yeah,
12 boys and girls.
that's
and
true.
then the remaining boys, and you minus 3.
Very good. I like that idea. So we're trying to figure out so
There's 12 boys in total.
yeah, so total amount of boys. You first have to figure what that is. It's gonna be 30 minus the 18 girls. So it's gonna be I like that idea, Nancy. So it's gonna be 30 minus 18, which is 12 boys. And so since we know it's 12 boys, we know that 3 are left-handed, so right-handed
9.
boys gonna be equal to 12 boys, that's the total, minus minus the amount that are left-handed. Okay, minus 3. That's gonna be what? 9. because we know that 12 boys are there in total. If 3 are left-handed, then if 3 are left-handed, then the remaining are going to be right-handed. So it's going to be 9 boys. 9, very good. Okay. All right, so that was easy. See, I told you math is easy. So we got that. And so let's move.
Hold on, Miss Petit, you can go back on the blast.
No problem. Let me grab this one time. Wow, it's already how it gets 7:23. I don't understand.
On your time, wrong?
Yeah, that's true. Thank you. Yeah, you're right. My time is wrong. Oh my, I should have taken the register a long time. Okay. Let me take the register. The day after Valentine's Day. Okay. Where are we? Okay, so we gotta go back here. Good. We good? Alright, so with that being said, let us move forward. So we need to figure out, we know they tell us that, sorry, let me put everything here so we could have it. So this table is important. Or should I just keep that? Let me keep that information on top there. I think that's important too. Yeah, let's keep it. Okay, good. So we are in BI. So they tell us that, hey, listen, a member, oh, let's complete the table again. Remember this one was 3, and this one was, so this is 3, this one was 9. So here a member is chosen at random. Okay, so what is the experiment here? Anyone remember?
So you just pick somebody out.
Pick someone out of your box.
Probability.
Say it again? All I heard was a lot of noise. What's the experiment?
Then picking someone randomly.
Yeah, picking a student randomly from the class, right? And it's an experiment because remember we said experiment must have a random nature to it. Now, what is the sample space? What's the sample space?
What you mean, like a classroom or something?
Oh, mercy, Nancy didn't ask that. We didn't just ask that. Oh, we went over this extensively. The sample space is going to be the total amount, the total possibilities that it's possible to get. So how much people are in the sample space?
30. Oh, 30. Oh, you mean the total number of people in the experiment?
Yes. Remember that's what sample now.
30 members.
So there are 30 members in our sample space, right? Now use your table to calculate the probability that the member is left-handed. So we want 6. No, remember probability is a fraction. You can't just say 6.
So 30.
6 over 30. 6 over 30.
Alright, so let's see. So remember probability, left-handed. Okay, that's how we write it. It's gonna be equal to
30.
It's gonna be equal to, this P stands for the probability.
Yeah.
Left hand is going to be left-handed. So the probability of left-handed is going to be, remember we said it's going to be, so the event, remember, the event is that we get a left-handed person. Okay. Now that left-handed person could either be a left-handed girl, all right? Or it could be a left-handed boy. And you notice how we use that idea of or, right? So left-handed girl or left-handed boy. Remember we said for or, we what? We add, okay? So it's gonna be 3 plus 3 all over 30.
30.
It's gonna be equal to what?
6.
6 over 30.
6 over 30.
Good. So it's gonna be 6 over 30. And of course, you know it's the next step. We have to
Simplify.
simplify. Simplify it. So it's gonna be equal to, we divide
1
both
over
sides
5.
by what?
6.
Divide both sides by 6.
1 over 5.
Yeah, 105.
5.
So we say how much times 6 goes into itself?
1 time.
Ones.
How much times 6 goes into 30?
5.
5 times.
5 times.
So the probability that we get a student that is left-handed is going to be 1 over 5. That's what? How much percent? How much percent that is?
Percent.
That's how much?
20%.
20%? You sure about that?
Yeah, that's 20%. Yeah, that's 20%. Don't worry.
20%. That's the kind of grades you'd be getting a Lionel. Because you know that you say that with surety. Yeah, that's 20%. Sound like you got that
Yeah,
before.
yeah, that's something I get in probability for true.
1 over 5. So it's 20% chance that we get someone who is left-handed when we choose a member at random. Okay, so it's 1 over 5. It's a pity that they only give us 1 point for this, but hey, that's life. All
And
right.
then half a point.
Say it again.
Better than no point.
Oh yeah, bet. Oh, I see. I see your point. You see that? I see your point. You got that? Ah. Oh. Kennedy is killing me. I saw the sarcasm in that laugh just now. All right. Okay, good. So now we want the probability that we have a boy. So we're gonna write probability of what? Boy? And that's gonna be equal to the boy either is gonna be what? A left-handed boy or a
Right-handed.
boy. So it's gonna be 3 plus 9 divided by 30. What is 3 plus 9? That's what?
12.
12.
And 12.
12.
Over 30. So we divide both sides by 6, eh?
4.
6 is better.
6.
6 is better. And so 12 divided by 6 is gonna be equal to what?
2 over 5.
2 over 5.
Who said that just now?
2, 5.
I said
I
it.
did.
And
I
someone
mean
else.
after you.
Rashay.
I think it was Cooper. Oh, wait, no.
So 30 divided by 6 is, what's 30 divided by
5.
2 over 5.
So 2 over 5. So the probability that we get a boy is gonna be 2 over 5. And that's 40%. So the 40% chance that we get a boy when we choose a member at random. And that's true. Normally there's more boys than there's more girls than boys in any room. Take for example this class. Oh, that's a good one. We can even do the probability in this class. How much people we have? So, but 34, yeah. And you could easily see that there are more females than males here. So that's usually right. So a girl is so we want a probability that we get a girl that's right-handed. Okay. So a girl and right-handed. So that's interesting. So we don't just want a girl or any girl. We want a right-handed girl. So
Would it be 24 over 30?
24 over 30? I don't think so. So let's see. So you want a probability that we get a girl that's right-handed, right? A girl and right-handed. It's crazy how they say it, but it's really meant to say a girl that's right-handed. But the and means something interesting. The and denotes something important, so that's why they put and. But it really is a girl that's right-handed. Now, we have 3 left-handed girls, so we can't consider that. A girl that's right-handed would be 15.
15.
So
15.
15. 15, and then we know 15 divided by 30. Not 15 divided by 30, but 15 goes in itself
once,
and it goes in
Once.
twice.
Twice.
So the answer is a half. Okay, we got that by dividing both top and bottom by 15. So the probability that we get a girl that's right-handed is going to be 15 over 30, which is a half. So there's a 50% chance that we're going to get a girl that is right-handed. Okay, next up is run the probability. Okay. The president of the club is right-handed. Calculate the probability. Calculate the probability the president is a boy. Hmm. The president of the club is right-handed. Calculate the probability that the president is a boy. So you want the probability that I don't understand why we had to put that, why they had to say that, but calculate the probability that the president is a boy.
Yeah, the grammar is so horrible. It makes it harder to understand these type of stuff.
No, they just want a right-handed boy.
I'm talking about
that's it.
I said, they didn't have to say the president. No,
they didn't have to say the whole president thing.
This is a club?
Say it again.
This is a club or something?
It is a club, yeah.
Wow.
This would be difficult.
Want to separate and divide.
Okay, so
Nine over 30?
9 over 30, that sounds right. I don't know why that for 2 points though. It sounds straightforward. I don't know why they would put up a third for 2 points. There's no extra step. So we want a probability that we get a boy and right-handed. Is it?
Yes, so.
And so it's going to be small from now. So it's 9 boys. That's right-handed. It's going to be 9 over 30. And we know that that could be simplified further, right? So we'd have, we could divide both sides by what?
2?
3. Okay, 3. 30 divided by 3 is going to be what?
10.
10.
And
And 9 divided by 3 is?
3.
3.
Can we simplify further?
Yes, sir.
I got
Yes, sir.
that.
So,
No, sir.
Can
No,
we
sir.
simplify further?
No, sir.
No, sir.
Okay, so it's 3 over 10. Okay, so
I got that.
that's the answer here. So calculate probability that the president is a boy. 3 over 10. I still don't understand why it's more points. It's, I mean, it's the same question. It's the same thing. They just want boy and right-handed.
Just like how we do girl and right-handed, I know.
Just like how you do. Okay. 2 members are chosen, one after the other, to represent the club. Calculate the probability that they are, first, both right-handed, right? That they are both right-handed. So let's deal with that one first. Okay, so we want the probability that we have that they are both right-handed. So, well, so let's first choose the first. Okay, probability that they are both right-handed. 2 members are chosen. Okay, so we want we gotta, what we have to do is, so the first time we select, right? The first time we select, we are going to select out of 30, right? But we only want right-handed people. And so, how much right-handed people we have altogether?
15.
15 plus.
Oh, sorry. 15 plus 9.
24.
15
24.
24 right-handed people.
24, right? 24 right-handed. Okay, so that's the first time. So the first time we select these people, we're looking for a right-handed individual. And so the first time we do it, it's going to be 24 over 30. That's the probability that we're going to get a right-handed person. So the probability that both are right-handed. So, but 2 members are chosen one after the other. So we have to be careful, because when we go to, so you're going to insert, and so let's insert something. So we have to be very careful. When we go back to, select again, okay? Let me go back to select again. Would we still have 30 people?
No, sir.
No, sir.
No.
I'm thinking if we ever change the sample space, both are right-handed. So the first one, when we do the first one, okay, so calculate the probability that the first one.
You wouldn't just simplify it or no?
No, okay. I'm trying to remember how we do it. Because there is a way. We have to take into account that we have to remember that when we do it the second time, one person is missing, and that person who's missing is going to be a right-handed person, right? Because we already took out so get 2 members of children, calculate the probability that both are right-handed. So we're gonna so we have to do the probability that the first one is right-handed times the probability that because we want both right-handed, both right-handed. So it's gonna be times the probability that the second one is also right-handed. So the first one had to have been right-handed. And so we only gonna have 20. 23 people, right? For the right-handed people. You agree?
Wait, explain it. You could explain
Yeah,
it.
because it's only going to be 3 people for... It's only going to be 3 people... Sorry, 23 people left because the first one we chose already was right-handed. So we're going to have... Because we making sure that both are right-handed. So the first one we chose had to been right-handed. You understand what I'm saying? There's only there's 24 right-handed people. So when we make our first selection, we had 24 people to choose from out of the 30. You understand what I'm saying?
Yes, sir.
But when we go again, we only have 23 people to choose from because we're looking for specifically right-handed individuals. If you understand what I mean.
So when we chose the first time, we was looking for left-handed people.
No, we're looking for right-handed. So that's why it's 24 over 30. Understand that?
I don't understand what you're trying to say.
I'm trying to say that, okay, when you select the first right-handed individual, right? How much more right-handed individuals you have still?
So how come it's 23 instead of 24?
That's my point right there. Think about it. You have 24 right-handed people, right?
Yes, sir.
Take one from them.
23.
23 is left. So you can't say that you still have 24 to choose from. You don't have 24 to choose from because you already selected the first one in the first option. Because remember, you're trying to figure out that both are right-handed, you know. So the first one have to be right-handed. So you already selected that one though. And the probability of you selecting that one was 24 over 30 because you had 24 people, 24 right-handed people at that, and it was out of 30. Okay.
I get that, Papa.
Now the second time when you already get the first individual who's right-handed. Now you're coming back again to choose another one. How much right-handed people you have now?
23?
23.
Yeah, you have 23 right-handed people. Okay. And so that's why the top number have to be 23. It cannot be 24 again. You understand?
No, we continue.
So, Mr. Petit,
Oh, what? All you're doing is moving the first right-handed person. Like, how difficult could that be? Down deep. And then so you remove the first right-handed
Mr.
person.
Petit.
Go ahead.
So we had 15 as the first one. So would it be 14? 14?
Yeah, it went 14. Yeah, it went 14. Now,
Okay.
the denominator, do we still have 30 people to choose from is my question.
Yes, sir.
No, we don't. No, we don't. Technically, we don't have 30 people to choose from. Sample space is total power. I'm struggling between whether it's supposed to be 30 or it's supposed to be 29. I'm not sure. So what I'd say is let's take a pen in this question. Because I'm not sure if the denominator is supposed to be 29 or 30. I'm not sure. So let's take a pen in this question and then we could do this tomorrow.
It'll be 30, right?
I'm thinking because technically it'll be 29 because, well, we don't have 30 no more. We took the first one out.
Yeah.
But if we look at the formula for probability, the formula for probability says total sample space. So they might
How we tried with 30 first.
yeah, I'm not sure. I ain't sure about that one. So we're gonna skip this one for now. I ain't sure about this one. There's another way we could do it, but that way is going to take too long. So I'm gonna do that. But I'm not sure if we put 29 at the bottom or 30 at the bottom. So give me till tomorrow to think about it. Okay. So DI and DII we can do tomorrow. Okay. Alright, so do we have time? I think we do. So we are given a quadrilateral. Okay. I went for 4 points. I hope that don't take
Mr.
it.
D,
Yes, sir.
we could go back, please, to the president.
To the president.
Yeah.
Okay. Right now? Or this one?
No. Next one.
Previous. This?
No. Yeah. Okay.
You good?
Thanks. I'm good.
You good? Alright. Okay. Okay, so let's do this one. Or should we do this one? Okay, so we have 10 minutes left. Okay, let's do
Number 8.
let's do the algebra one for the night and then call it caps. And then we can do number 9 tomorrow. Okay. Okay, so solve solve for x. This isn't that bad, you know. Like my teachers say, there's different ways to skin the cat. This one, there's definitely multiple ways we could do this. The easiest way, in my opinion, honestly, let me show you the easiest way to do this, in my opinion. So the first thing you want to do is immediately get rid of that denominator. So we have those denominators. So we have 1 over x minus 1 over 2x plus 1 over 3x equals to 1 and 2 over 3. Excuse me. That's expressed as a mixed number. So 1 and 2 over 3 is going to be equal to how do we express it as a mixed number? What do we do? How do we take 1 over 3 and express it as a mixed number?
3 times 1 equals 3 odds 2 5 over 3.
Do it again.
1 times 3 equals 3 and add the 2, make it 5 over 3.
So 5 over 3. Anyone agree with that?
There you go. Yes, so you multiply then add, and then keep the denominator.
Very good. So we multiply 1 by 3, and then we add. So 3 times 1 is 3, plus 2 is 5 over 3. So this answers are definitely going to be 5 over 3. So instead of putting 1 and 2 over 3, I just put 5 over 3. And then what we need to do is we need to find something that we could multiply every term by to get rid of the... I want to get rid of the x, I want to get rid of the 2x, I want to get rid of 3x, I want to get rid of this 3. So we need to find a number and variable that if we multiply it by this term, this term, this term, and this term, everything will cancel out. So I immediately think if we do lowest common multiple, we'll get 6. So definitely 6 would work. So we take 6 x. And the reason why I'm saying x is because x is common in all three of them. So we're going to multiply every single term by 6x. It should be clear why I choose 6x, because we have the 2 and the 3, and an x3, and the LCM is 6. Okay, so we're gonna take 6x and multiply that by every single term. Again, 6x multiplied by every term. And so what happens here is, well, this x goes with this x. This x goes with this x. And 2 goes in itself how much times?
Once.
How much times 2 goes in?
Once.
How much times 2 goes in?
3.
3.
3 times.
2 goes, and then we cancel this x with that x. And this 3, how much times 3 goes into itself?
Once.
Once. How much times 3
Once.
into 6?
Twice.
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 And then this 3 goes
Into itself once.
How much times?
Twice.
Twice. Good. So we are left with just 1 here. Minus just 3 here. Plus just 2 here. It's gonna be equal to 2x times 5. So 2x times 5.
And 2x.
5 times 2 is 10.
10.
10 what?
10x.
10x. Good. It's gonna be equal to, what is 1 minus 3 plus 2?
Mr. T.
Go ahead.
Sorry, I just have a quick question.
Uh-huh.
When you multiply the 6x by all of the numbers, do the numerators, don't you add x to them as well, or no?
No.
Why?
Because there's no x on it. Like, we just say, for example, this is just 1. So this is also 1. So 1 times 1 is just 1. Similarly, 3 times 1 is 3.
3.
2 times 1.
2 times 1
is 2.
Is 2.
And 2 times 5 is 10.
10.
But here we have the x. So that's why we put the x still.
Oh, because that x wasn't cancelled.
No, it wasn't cancelled out. This wasn't cancelled out.
Okay.
Okay.
You can repeat how we get 10x, please.
Okay, 2 times 5, which is 10, and the x right here.
Oh, so we bring down the other numbers, right?
Yeah, we just bring on the other numbers.
Right.
Okay, what is
Mr.
1?
Petit,
Yes, sir?
I missed the part where you got 6x.
What you mean?
6x. I missed that part. Like, how did you get that?
How do I know it was 6x?
Yeah.
Because remember we had x, 2x, and 3x. And then 3 again. And we know that the LCM of 2 and 3 is 6.
Okay.
Yeah. So what is 1 minus 3 plus 2?
5.
5?
I mean, sorry, no, sorry. Sorry.
So what is 3 plus 2?
5.
What is 3 plus
Negative 4.
Negative.
Sorry, negative 3 plus 2 is going to be what?
Negative, that'll be negative 1. Negative 1 plus 1 is 0. So just be 10x.
So 1 minus 1 is, this don't make sense. 1 minus 1 is 0, leaving us with 10x And if we divide both sides by 10, we are left with x is equal to, what is 0 divided by 10? What is 0 divided by 10?
You say what's 0 divided by 10?
0?
Yeah.
0.
0.
0.
Good. So x is?
Let's see.
Yeah.
You could repeat the part where you get 1 minus 1, please, because I didn't hear that part.
Okay, so what is negative 3 plus 2?
Negative 5?
No.
Be negative 3. Negative 3 plus 2.
Negative 3 plus 2 is negative 1. Isn't it?
Yes.
Yeah, you owe someone $3. You have $2. Pay them what you owe them. And so you still owe them
Alright.
1. You see what I'm saying? And then so 1 minus 1 is 0. And then we divide both sides by 10. So we get that 0 is divided by 10, which is 0. And so x equals to 0. But we have a big problem. A big problem. Can x be 0? In this case?
No.
Why?
Nope.
Why?
Well, I'm just like a guess because I think isn't it supposed to be a value greater than 1?
No, it don't have to be. Why? Okay, tell me why.
I don't know. In my head, it just don't sound right.
Oh, just because it don't sound right? No, darling.
No,
I mean,
I don't know.
It don't feel righty.
No, that's why I'm trying to figure out what's the issue. Just know it don't sound right, but
Yeah, so the idea is that if x is 0, then this term would be, so 1 over x would be 1 over 0, right? What is 1 over 0? Can we do, what is 1 divided by 0?
0?
Bro.
No, sir.
error, and that's error.
Yeah, it's undefined.
Impossible.
Okay. We could do 0 divided by 10, but we can't do 1 divided by 0. So we can't have zeros at the bottom because if x is 0, this will be 1 over 0 minus 1 over 0 minus 1 plus 1 over 0. But we can't have 1 divided by 0 because it's undefined. So what I'm going to do is I'm going to check my answer first.
Must be confused.
You're confused? Okay, tell me where you're confused. Go ahead.
I can play it back when you send it.
You sure?
Yeah, because I confused.
You're confused. Okay, well, all I'm trying to say is that if x is 0, that means that this is going to be 1 over x, and x is 0, so it's going to be 1 over 0. And 1 over 0 is impossible. You can't have 1 over 0. And then 1 over 2x. Well, 2 times 0, because x is 0. 2 times 0 is still 0, so it's that this will be 1 over 0 is 2. And then if we have 3 times x, x is 0, and so that'll be 1 over 0 again. So all we have is 1 over 0 minus 1 over 0 plus 1 over 0. That don't make no sense. So x cannot be 0 here. Even though we get x is 0, x cannot be 0 here. So we need to see before I make my statement, I want to check and see if my answer is right. And then if it's correct, then there's a statement that we have to make concerning this question. So you can always use something like Maths Papa to check these stuff. So the equation that we get was 1 over x minus 1 over 2x plus 1 over, what else it was? 1 over 3x is equal to 5 over 3. And what did they get? Let's see. A half. Okay, so we did it wrong. Multiply each term by x. 1 minus, okay, so let's see. 1 over x, 1 over 2x, 1 over 3x, 1 over 3. Okay. Multiply all terms by x and cancel. So if you multiply all terms by x, we get 1 plus negative a half plus 1 over 3 equals 5. Oh, okay. Simplify both sides of the equation. One minus a half. This is 5 over 6. Okay, so they're getting a half. Plug in the original equation. Yeah, that's, I figured that 0 is crazy. Okay, so where did we go wrong is our question. I know we passed 8 o'clock, but let's check this before we go. Okay, so far we did everything right. We multiply everything by x. Ew. Oh, we made a big boo-boo. I don't know if y'all see it.
Wow.
So the idea is that only this x and this x supposed to go. We still had the 6 and the 1. See that? So the 6.
I got a bad feeling.
Yeah, so the 6 did not go. So it's supposed to be 6. Okay, so it's supposed to be 6. Alright, so made that correction. So 6 minus 3 plus 2. Okay, so 6 minus 3 plus 2. So that means that everything at the bottom here is wrong. And so we need to correct that. So I'm going to put the rest at the bottom here. So we are left with 6 minus 3.
So you're saying that the way you mark out the 1x, I mean the 1 over the x, that's supposed to be 1 over 6? Or just 6?
What I'm trying to say is that we mark out the x. Only the x is supposed to be marked off. We wasn't supposed to mark off the 6.
Oh,
There's no 6 at the bottom, you see?
In my book, I didn't mark off the 6. I don't know.
Yeah, we didn't mark off the 6. I forgot to multiply the 6 and the 1. Because 6 times 1 is going to give us 6. And so it's going to be 6 minus 3 plus 2. It's going to be equal to 10x. And what is this is still negative 3 plus 2, which is what? What we can do first, what is 6 minus 3? 3 plus 2. It's going to be equal to 10x. And then 3 plus 2 is what? 5.
5.
10x.
10x.
Then we divide both sides by
5.
10 by 10. I'm trying to get rid of the 10 in front of the x. We cancel. So x is going to be equal to 5 over 10.
You switch it.
So x is going to be equal to 5 over 10. What is 5 over 10 though?
A half. 0.5.
Right.
Because 5 over 10 is a half. Okay, so the answer is x is equal to a half, like we saw. Any questions on that?
On that.
Yeah.
and practice
Sure,
my
there's a lot of
12
questions.
skills. Make sure I get it down pat and be able to play it slow
How
and
you get the
fast.
10F?
I can practice, I can focus on
How we got the 10?
my 12 major skills and the 12 minor skills. That's what I can focus on.
Who's that speaking?
And then, yeah,
Oh,
that's basically it. I can focus on like now. Then later in the summer, I can focus on the chromatic and all them different other skills.
well,
Oh, yeah.
okay, so yeah, so he asks, how do we get the 10x? Remember here, 2 times 5 is 10, and we have the x here. Okay, you see that? John, 1.
Yeah, I see that.
Any other questions? Yeah, I'm sure y'all have more questions. Just, but still, send the notes in. Maybe we could do it again and we come back again, just so you have a cleaner version of it. But send in all the send in all the.
So it's between.
Go ahead.
You could have put the answer could have been a half or x is equal.
Say it again.
Could have x is equal to a half or x is equal to 5.
No, you can't say x equal to 5. It have to be x equal to a half because 5 over 10 simplifies to a half. You understand that?
Oh.
So send in the notes for me. Thank you, Albano. For the rest of you, please send in the notes for me. And we're gonna continue our discussion on tomorrow. I don't think we ever had to skip a question. A probability one, man. So we can check that out tomorrow. That still have me in the dance. I'm like, what do we do for?
Yes.
Yeah, so we gotta check that out tomorrow again. Okay, so that's it for now. I'll see you on tomorrow at 6 o'clock. That'll be day 3. Wednesday already, right? I can't believe it. I just can't believe it. But that's day 3. And so see you tomorrow, 6 p.m. For those who are staying for general, then health, we meet now. Okay, so we are going to begin. I think I have a quiz for you guys. I think I have a quiz for you. Let's see if I have it here. I think I have a quiz for you.
Pop quiz?
I hope it ain't no hard one.
Yeah, this one might be very hard. It's we'll see how it goes. This is going to be on deficiency diseases. So let's see. Okay, can I have it? Okay.
Firstly,
Say it again.
we don't have.
All right, so let's begin. All right, so balanced diets are never important to us, unnecessary to us,
Very important.
or
Very important.
one. C. Okay, good. If
Let's go.
unbalanced diets continues blank of the time, the person may suffer from disease. So if unbalanced diets continues over a short period of time, over no period of time, over a long period of time, over 2 years.
A.
I think it's A.
A.
I think it's A.
I think it's D.
All right.
Yeah.
Oh.
I knew I was wrong.
Yeah, it's better.
I said that. Happy length.
I say B, but I still was close.
Wait, what?
I said C. Oh, yes.
Yeah. So it's over a long period of time. If it continues for a long time, then of course the person will suffer from diseases. Okay.
Can't even blame the B.
Diseases which are caused by blank of some vital nutrients over a long period of time are called deficiency diseases.
Is either B or D or C or A.
I think it's B.
Diseases which are caused by blank of some vital nutrients over a long period of time are called deficiency diseases.
I think it's
A or D. A or D.
No.
Or C.
B.
C? Someone said C. Okay, let's see. Deficiency.
Yes, sir.
Yeah.
Yep. So diseases which are caused by what? A deficiency of some vital nutrients over a long period of time are called deficiency diseases. Okay. Deficiency of blank and blank cause a whole lot of diseases. Deficiency of vitamin and minerals, deficiency of vitamin A and vitamin C, vitamin B1 and vitamin C, or minerals and vitamin C.
Is either A or D?
I think it's B.
I think it's D.
Try me A.
I heard someone say A.
A or B?
A.
A or B?
A or
A
B?
or
Which
B?
one?
Go with it.
A.
I think D.
Go with it, motherfucker. Go with it. All right then.
Yes. Let's go.
Let's go.
I was going to say D.
All right. What causes the deficiency of skin-related diseases? Vitamins, proteins, minerals, or calcium?
I think it's not calcium because that deals with the teeth.
I think calcium.
And calcium?
I think protein. No.
Protein.
Oh, I was right.
Let's see how you can collect answers first. He didn't say.
He did say
protein.
calcium. He did say calcium.
I said protein.
That's on my body.
He said calcium. What deficiency causes stunted growth in a person and makes them weak? Deficiency of proteins, vitamin A and C, deficiency of fats and carbohydrates, deficiency of vitamins.
That'll be a C.
C.
That'll be a C. B or C is one of them.
C. Deficiency of fats.
All right.
Yes.
All right then.
Let's go.
Loss of vision is caused by the lack of.
I think vitamin D. Is that vitamin A?
D.
C.
Vitamin
D.
Is vitamin A?
Vitamin C.
Trust me.
D.
Vitamin C.
D. as in
D.
D.
Is that a B or C?
What?
Mas você comigo para B, no.
What?
D.
D as in dog?
Okay, let's go Kennedy on.
Mas D is D.
All right then.
Thank
Let's
you.
go.
Let's go.
I was right.
All right. What disease is caused by a lack of vitamin B1?
I think rickets or scurvy.
It's rickets.
Rickets. Try rickets. Try rickets.
I think
Very.
think this.
Very.
Very.
I was thinking that in my head, you know.
All
I
right.
got that one.
What is
Does he done say rickets?
no, very. I didn't say rickets. Check.
So, this
What
time
disease is caused by a lack of vitamin C?
Is that a D or C? D or B?
D.
It's D.
A?
Try rickets.
Girl.
A, someone say
No.
No.
D. It's D.
Hey, y'all listen to the person.
what am I listening to?
I promise. I know him. No, I promise it's scurvy. I promise.
scurvy.
I put it on.
100%.
It's B.
I know this
It's
one.
scurvy. Try scurvy.
It's
It is.
Exactly.
Okay then.
Yes, sir.
All right. Lionel. Rickets is caused by.
Oh shoot, I catch you on that one.
See?
I think deficiency of vitamin D or A or B or A or C.
I think it's A.
One. Or this one.
Ay.
I think C.
I think A.
Try deficiency of vitamin D.
Vitamin what?
C.
D.
This?
It's vitamin
No, D.
I know. No.
Vitamin
C
D.
means C.
This?
C.
I think it's A.
I know. Oh, okay then.
All right. So vitamin D. Okay. Rickets is caused from deficiency of vitamin D.
That's a tough question, though.
What is Goiter caused by?
Oh, iodine. No.
Deficiency of iodine.
Try iodine. Try iodine.
He's looking at it too.
Because
iodine. It's iodine.
There you go.
No, I'm like
getting everything correct.
What causes mental disabilities in children?
Ooh. Is that a D or D?
I think it's D.
Try.
I think it's D.
Try D.
Try D.
Yeah, try D.
No, you got it wrong.
What's iodine?
Yeah, I didn't know. So I can't help you.
All right. Tooth decay is caused by deficiency of what nutrient called what?
A.
That's A. That's easy.
Vitamin
A.
A.
No.
A. Not even A. A is an apple.
Vitamin A. Y'all say vitamin A.
Vitamin C.
I'm not A.
Oh, A. Vitamin A.
Yes.
No.
No, vitamin C.
Oh my gosh.
Okay. Anemia is deficiency of blank in the body.
Iron.
Yeah,
Iron. Very
Yes,
good.
sir.
Yes, sir.
What causes the
Yes,
extreme
sir.
weakness in the body?
It's vitamin C.
Vitamin C.
That's wrong.
No, iron.
That's anemia. What can happen if you have an unbalanced diet?
A.
Suffer from diseases.
Suffer from diseases.
We get this.
Oh, it's pretty on there.
What is
For real.
deficiency disease caused by?
A and C. I mean vitamin C.
I think he said C.
No, it's C. It's
B.
Hold on. No, C.
B.
Oh, you're right. You're right there.
Yeah, then. Go on then.
We'll get the answer right there.
What does the deficiency of protein cause?
Ooh.
Yeah.
You are A.
Say it again.
A.
A. It's correct. Skin related.
I right there.
Yeah.
What is the deficiency of fats and carbohydrates cause?
B.
So that's
Try B.
B.
Alright,
Okay, then. Y'all gone then.
what are the
Y'all
symptoms?
be smart.
We almost done. 10 more questions.
A.
What are the symptoms of
A.
lack of vitamin?
A.
A as A. Loss of vision.
Yeah.
Yes.
Okay, then. Para.
Berry.
C.
Berry is a lack of vitamin one.
C.
Berry.
Try. Is that a D or B, boy?
C.
C.
Try C.
C. Vitamin 1.
Yes.
We're in a row.
Oh, then.
What are the symptoms of berry?
Ooh.
Um, it's not. Wait, let's
I
see.
think it's A.
I think it's A too.
Try A.
It can.
No, don't try it. Don't try it. Don't not. No. Not hold.
Oh no.
See.
It's,
What? Oh yeah. No.
I'm like, go.
See.
C. It's C. Yeah, C.
Go with C then.
It's C. What the?
Yeah, go and see then. That's C.
I was right.
I know. They're wrong.
I was right, man. Mother.
Wow.
It was in me.
Talk about C.
It was Lionel.
Y'all putting so much faith in other people, man.
Lying in the spinner.
And everybody saying they and these talking about go with C.
All right. If you have scurvy, what vitamin do you lack?
C, B, the letter
C.
B. The letter B. The letter,
You got
Which one?
the letter B.
The letter.
No, the letter B.
Oh,
one
vitamin
trust me with
B1?
this.
The letter B.
No. Vitamin C. That's my
C.
one time.
Vitamin C.
Vitamin C.
All right, perfect.
Her.
What disease do you have if you lack vitamin D?
We just went this. Yeah, yes.
What disease do you have if you lack vitamin D?
Oh, that's a good one.
We just went through this.
Ooh.
Rickets.
I know. Like,
C.
Cat records.
No cap. C. Rickets.
It's cat records.
Yeah.
Rickets. No cap. No cap.
Right.
No
Yeah.
cap.
Her.
No cap.
5 more. What disease do you lack by iodine?
Quarter.
A.
Why not?
Goiter.
Oh, he said that real? Oh, okay.
What disease give people a swollen neck?
C.
Quarter.
Goiter.
Okay then, y'all go then.
What happens when you lack calcium?
Tooth decay.
Two decay. Two decay.
Decay.
No.
Tooth decay.
Yeah, two decay. Because I did.
Right. Okay.
Exactly.
No, you go material girl.
What nutrients
Yeah,
do you need
calcium.
for strong white teeth?
Calcium.
A.
Yeah. Calcium.
Calcium. Yes, sir.
What are the symptoms of anemia?
Weakness in the. Oh, hold on.
Weakness in the body.
I think C.
No, yeah, it's weakness in the body.
Weakness in the body.
C.
No, weakness in the body.
Weakness in the body.
C.
Yes.
C.
Yes.
Yeah, boy, I pray, please. Oh, good.
So that means you'll be guessing and answers.
If you have bleeding gums and wounds, take a long time to heal. What vitamin do you need?
I think it's A.
B,
A.
A and C. Vitamin A and C.
Vitamin is
I am so curious.
Vitamin
C. C.
There's no way, bro. There's no way.
And no,
That's a question, Rick.
All right.
Sam,
73.
I want to do this again.
73. So y'all got
I want to redo. Dine,
4,
chapter
5, 6, 7,
yeah, no.
8 wrong.
We gotta redo this. This is chapter 4.
Y'all.
That's not okay.
Okay. All right.
You gotta let it slide on that one.
All right. Let's continue.
Yeah, don't this one.
Okay.
This chronic stress takes a toll on the body.
Okay, we ain't talking about what is health now. Okay, so let me try something. Can y'all hear this? Let me see.
Contributing to many chronic diseases.
Y'all can hear
May
it?
also lead to unhealthy
Yes, sir.
coping behaviors.
Y'all can hear it?
Yes, sir.
So, when talking to your patients, consider
Yes,
their
sir.
social context.
Okay.
Factor it into your clinical decision.
Okay, so we're gonna do some videos next class then. Since y'all can hear it. Okay, so that's all the time we have for health, for general. That was health or general?
We're doing general first.
That's health.
That was health. Why did I do this
We
first?
do help.
That's health. Just gonna say all them vitamins. That's health.
You go finish to help. I'm sorry, you go finish to help.
Before you start, I did say, Mr. Petit, this health or general. You ignore my question. So I just sit back and relax.
So finish to health history. I start and I finish to it.
Yeah, that's
I'll
we
just
all the
finish
time.
it
We all
then.
the time. So we're gonna just finish off.
So,
General.
yeah, it is near.
I can't believe I did this. Those will do general first.
Why you Western? Why you went for general?
All right. Okay, so last time. Okay, so that's just a review. So now we on general. So last time we.
See you later, Mr. Boutique.
All right, Miss Cooper.
You should write just to help us one time.
General.
You already started, so might as well finish it.
Yeah, we already finished that though. General science. So last time we was on was lab safety rules. We talked about the different rules that are important for safety in the lab. And so that's what we was talking about on last class. Today we're gonna move off of that, and for the next several minutes, 30 minutes or so, we're gonna talk about something else. So today is Tuesday, not the 8th, but the 15th of February. This is General Science. And like I said, last time we was talking about lab safety rules. Today we're gonna switch off of that topic and move to something else. Okay, so what I want to move on to is, let's just we're supposed to know this already. All of us here are familiar with the characteristics of living beings, right? Movement, respiration.
Yes, sir.
Okay, so that's good. So we don't have to do that. What I want to do now then is let's talk about the differences between the plants and animals. Okay, so let's construct this table. You know, every time we come out, the table we're gonna make. Okay, so let's make it a little pretty. So on the first column, you're gonna have the plants, and then the second part, you're gonna have the animals. So what are the differences really between a plant and an animal?
Plant makes their own food by photosynthesis. Animals.
That's
don't.
Nathan, right? Nathan speaking.
Yes, sir.
Okay, so yeah, definitely plants make their food by photosynthesis. But let's talk about the movements, right? So when we consider the movement of an animal, we know that the whole organism usually moves from place to place. So take down these notes for me. When we say we mean, if we look at your body and let's say if I say walk from here to the mall at marathon, like your whole body, you yourself is going to move. So and if we see a cat running or a dog, chasing a car, the whole organism is moving. All right. So when animals move, their whole body, as a general rule, moves. But do plants move from place to place?
No, sir.
No, not by themselves. So, but a plant could move in a way. In a way, they could move. In a sense, they could move. Say, for example, if you have a plant and the plant is trying to get more sunlight. You ever see like the plant grow and it's leaning? You ever saw that? Like the plant is growing, but then what happens is because the sunlight is in a particular area, it would bend towards where the sun is. You ever saw that before?
Nope.
You never saw that before? Like, say, for example, if we have the sunlight, so let's use a bright yellow for sun. If you have the sunlight over here, and the plant is over here, the plant, when it grows, it's going to, sure, it's going to grow, but as it grows, it's going to say, man, I need more sun. So it's going to grow towards the sunlight. And so you would see some plants bending, you know, they have a bend towards it. Okay. Never saw plants like that? Bending. You ever saw a coconut tree bending?
Yeah.
Yeah. So they bend because what? The state bending to get more sunlight. And so in that sense, the plant moved, right? It bended towards the sun. So that's how we say the plants move. Excuse me. But plants don't move in the sense that we move. Like how we move our whole body and, you know, from place to place. No, not like that. They move parts of their body. So plants are gonna move parts of themselves. Okay? So they move parts of themselves, not their entire body. The next thing is that they do not usually move from place to place. Of course, we mean by themselves. They could move from place to place if people transplant them, but by themselves, no. They typically don't move from place to place, like how we do. The next thing is that, and Nathan mentioned this already, green plants are producers. Okay, so that means that they are going to be the ones to make their own food. So green plants are producers. They make their own food by photosynthesis. Now, on the contrary, animals are, what do we call them? What word we use for them? They are not producers, but they are what?
Consumers.
Consumers. Very good. They are consumers. They cannot make their own food. But they obtain it. They obtain food by eating plants and or other animals. So they are consumers. They cannot make their own food. They obtain it by eating plants and or other animals. Number 3. Plants. Let's go to animals. Animals, they respond rapidly to stimuli. So if what I mean is there are different stimuli. So we have light, we have temperature, we have sound. So you easy test it. Like if you throw a rock at a dog, you know, it'll quickly try to dodge it, right? Throw a rock at a tree, and the tree doesn't move out the way, it stays. So it responds quickly to stimuli that comes, and animals they react quickly, right? But plants they don't react quickly. They take long to react. So let's go. So animals usually respond how? Rapidly, right? Animals respond. They usually respond rapidly to stimuli, right? And this is usually a temporary change. So animals respond rapidly, and it's going to be a temporary change that they have. But plants are going to respond how?
They take a little while to respond.
Yeah, they respond, we would say, slowly to stimuli by what? Moving parts of themselves as they grow. Like we said, if the plant is away from the sun, it will try to tilt to become closer to the sun, right? And that change is not temporary. Okay, that change is not temporary. It is permanent. So usually respond slowly to stimuli by moving parts of themselves as they grow. And we see that this is usually a permanent change. So they usually respond slowly to stimuli by moving parts of themselves as they grow, and this is usually a permanent change. Now, so that's some differences between plants and animals. The next thing I want to talk about is levels of organization of an organism. And then we're going to talk some more about, if we have time, about the differences between plant and animal cell. So everything have organization. What I mean is that think about it. If we look at your school, there are levels of organization, right? So your school, let's say for example the government school system, a group of students along with a teacher, that's a classroom, right? So if you have a group of students and a teacher, that's one classroom. But if we have multiple classrooms, that makes a what?
Repeat that.
So a group of students and a teacher is one classroom, right?
Mm-hmm.
And then multiple classrooms is what? Together, multiple classrooms is what?
A school.
A school, very good. And then multiple schools is what?
Teachers.
No, multiple schools is what we call
Ministry.
a district.
Uh,
Right?
Not ministry, administration. Sorry.
Yeah, multiple schools is a district. So you have classrooms, then schools. So classrooms, then bunch of classrooms come together, gives you a school, then schools and multiple schools together give you a district. And then multiple districts gives you a what?
Administration.
No. We have different districts. So we have the southern, um, we have the different districts, different school districts in the Bahamas. So once you have multiple districts, then they all come together to give you, I forget the word that they use for it, but basically, they come together and you have all of the schools in the nation combined. So the idea is that smaller things create bigger things, and those bigger things create more bigger things, and those more bigger things create more bigger things. And so that's what we mean by levels of organization. Now, when we come to the body or um, an organism, there are different levels. The smallest building block, right, that is itself living as well, the smallest unit of life is called the what?
Cell.
The cell. Okay, so the smallest building block, all organisms is the cell. So that's the smallest level of organization. Good. Then after the cell, moving on, we have groups of cells come together. They give us the what?
Tissues.
They give us tissues.
Tissues.
Good. Not tissues in the bathroom tissue, not that type of tissue. Okay? Body tissues. So cells come together and give us tissues. And then tissues, groups of tissues come together. They give us what? If we have a bunch of tissues come together, that gives us what?
Organs.
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 And then if we have a group of organs to come together,
The body.
that gives us
System.
systems. So we have the cell, put this over here. Groups of cells come together, gives us tissues. Groups of tissues come together, that gives us organs. Groups of organs come together, that gives us systems. And groups of systems come together,
Body.
the body. All right. So this is level of organization of, we can say the body or an organism, because here we're dealing with general science, so it's not just the human body we're thinking about, but we're thinking about organisms as well. And so this is our level of organization of an organism. So we have cells, which makes up tissues, which makes up organs, which makes up systems, which makes up the human body or an organism. Okay? Are we good?
Yes, sir.
All right. Okay, so here it says that a cell is the basic unit of all living organisms. For example, we have the iris cell, iris muscle cell, and the iris is found in the eye. So a group of cells can work together a group of cells can work together to perform a specific function. So a group of cells can work together to perform a specific function. In that case, they will be called tissues. So they are called tissues. For example, the iris of the eye. Now a group of tissues can work together a group of tissues can work together to form an organ. So group of tissues can work together and they could form an organ. Give me an example of an organ.
Liver.
The liver.
Kidney.
Kidney.
Heart.
The heart. And the eye. Okay. Those are examples of organs. Now, when organs work together to perform a function, the group is called an organ system. Now, examples of this. So examples would be what? Of systems in the body.
Skeletal.
Skeletal system.
Nervous.
Yes, nervous.
And circulatory.
Okay, anyone else? Circulatory?
Respiratory.
Yeah, respiratory system. So circulatory system. Respiratory system.
Reproductive.
Reproductive system.
Endocrine.
Digestive.
Yeah, digestive. System. And what else someone said? That's it? Okay, so muscular system and so on. So we could go on and on and on. Okay, so the body of the organism the body of the organism okay, so I didn't realize I was pressing M. Okay, so the body of the organism consists of a number of what? Organ systems that work together to keep the organism alive. Okay? Alright, so we're gonna end there tonight. I'm not gonna push it any further. Next time we come, we could be talking about the differences between plant and animal cells. Okay, so basically all we did was mention the features in plants and animals that are different, and then we break down and start talking about the levels of organization, be it the cells, the tissues. Like we said, groups of cells that work together form tissues, group of tissues that work together form organs, group of organs that work together form the systems, group of systems form our entire body. Okay, so let me know if I could move this. Are y'all good? You got this down?
Go back up.
Go back up somehow. How up? Is it good enough?
A little bit more.
Okay.
Thank you.
Okay, good, perfect. So for those of us who have to leave, have a wonderful night. Thank you all for coming and showing up. And I'll see you on tomorrow. That's tomorrow at 6 p.m. where we continue our studies. Okay? All the best and take care. Have a wonderful night, everyone.
Bye.
Yes, ma'am. Have a good one.
Good night.
Good night. Good night.